Hello, this lesson is on similar figures, and to accompany you in watching the video, you should have a little handout given by me in class. So we're going to start off filling in our first characteristic or criteria for similar figures, and this is corresponding angles of similar figures are congruent. So for two figures to truly be similar, the angles which correspond should be congruent or equal measures. Remind ourselves what congruent means for angles. They're going to have the same measure. And then corresponding sides of similar figures are proportional. Now, they are not going to be congruent like the angles, because that would make the two figures exactly the same and therefore congruent. When they are similar, they have a relationship of the sides, which we call proportional. And we will demonstrate what proportional means on this example here. So what I have is a statement. You may notice that it looks a lot like the congruent statement, but I have my similar symbol in the middle. Let me just kind of make sure that's really clear there. And that symbol, instead of congruent, like we were using before, does mean similar. So this is a similarity statement. Now, with our similarity statement, we can still see the parts which correspond. And in this case, we can see that angle A corresponds to angle X, and that is because they are the first letter in the position. So I can go ahead and mark A and X with the same marking because these two angles are congruent. Similarly, I have angle B corresponding to angle Y. So I know angle B, which I will mark differently, is congruent to Y. And finally, angle C, congruent to angle Z. And I will give those their own unique marking. Now, as far as the sides being proportional, what that means is if I make a ratio of sides, for example, if I take side AB, that one from my statement corresponds with side XY. I can put those two lengths together in a ratio or fraction. And when I divide the measurements of those two sides, they are going to be equal to the ratio of the other pairs of corresponding sides. Similarly, BC and YZ correspond. So I know that AB over XY, or AB divided by XY, is going to be equal to BC divided by YZ. And finally, we have AC and XZ. So that's going to be equal to AC divided by XZ. Now, what is very important is that all of my sides in the numerator of the fractions come from the same triangle, and all of my sides in the denominator of the fractions come from the same triangle. So I've been consistent in how I have set these up. Now, for these three ratios to be equal, that is what proportional means. So we have, let me start over there, we have equal ratios, which is what proportional means. Now, we are going to see that in an example with example 1, state if the polygons are similar. So I do want to go through that checklist, which I see here, the two criteria that make figures similar. I want to have corresponding angles congruent, and I want to have corresponding sides proportional. So looking at my two figures, I have these little square markings in every angle. Recall that that does mean these angles are 90 degrees, and they are all then congruent. Now to check if the sides are proportional. So if I make myself a little checklist, the angles are congruent, check, that is true. And now are the sides proportional? So taking the sides which correspond would be AB with LM. If I go and put those together in a ratio, AB is 10 over LM, which is 5. This is 10 divided by 5 when I go to simplify, and that is equal to 2. Now I noticed that because this is a rectangle, DC and ON have the same measurements, so I also know that DC over ON will equal 2. Now going on and checking the final pairs of sides, I have AD, which corresponds to LO. So AD, which is 16, divided by LO, which is 8, is equal to 2 as well. And then similarly, BC and MN will have that same ratio of 2. So as I see that all of the ratios of the sides are equal to 2, that does tell me that the sides are proportional because the ratios are equal. So I can go ahead and do my check mark. Yes, I have proportional sides. So my final statement is going to be yes. And then I can go ahead and write a statement. A, B, C, D is similar to L, M, N, O. And I want to go around the figures in the same order. I do not need to start with A, but I can start with B or any other letter, but I need to go around the outside of the figure in the same order. All right, moving on, we have our same directions here. So I want to check, are my angles congruent? Now what I have here is a pair of parallelograms. And there are some properties about them which we can apply to help us figure out more of the angles, because as I see right now, angle 60 and 120, that's not telling me that they're congruent. But I know in a parallelogram that the sides that are consecutive to each other, like W and Z, those are equal to 180 degrees. So if I take 180 minus 60, I get left with 120. So I have a 120 degree angle there. Angles opposite of each other are congruent, so that's Z and X. X will be 60 as well, and then W and Y are opposite, which makes Y 120. So going similarly around PQRS, I will know that this will have to be 60, 120, and 60. So yes, I do have angles being congruent here. So check. Next, I want to check if sides are proportional. So I'm going to go in with my ratios. For example, WX corresponds to PQ. So I would do WX of 35 divided by PQ of 42. Now I do want to simplify my ratios, so I can do that by simplifying the fraction, or I can go ahead and calculate a decimal version of this ratio. That's what we might find the easiest. And I'm seeing that when I divide this in the calculator, 35 divided by 42 comes out to 0.83 repeating. All right, I know that that's going to be true for my pair Z, Y, and SR. So moving on to my other pairs of sides, I have WZ corresponding to PS. So that's 35 divided by 60. Now you may already notice both of them have 35 in the numerator with different denominators. So that is going to give us a different ratio. 35 divided by 60 is actually 0.583 repeating. So as you can see, these are different ratios, and so no, the sides are not proportional. Therefore, W, X, Y, Z, and PQRS are not similar. Okay, and then I want you to pause the video to try the final example on your own. Back to our final example, we could see that the angles are in fact congruent. I do have all pairs of angles with the same angle marking. So no solving needing to be done here. I also see when I set up the ratio of my sides that each of them do come out to 1.2, which means that the sides are proportional. Therefore, figure HIJK is similar to RSTU. Okay, so we're going to be moving on to our second type of example. In these examples, we are told the polygons in each pair are similar. So the polygons already are known to be similar. Find the missing side length. So I need to find the side length, the missing one, which is going to be our one that is indicated with a question mark. So I need to be taking that assumption that similar figures have proportional sides, and I want to still set up these sides in a ratio, being consistent. However, with my unknown side, I will replace it with a variable. So putting this into two fractions, I would take my sides which correspond, one that I don't know and one that I do, which is x and 3. And then looking at my other pair of sides, it should be two sides that I know the length of, which is 12 and 4. So I just want to be consistent in how I set these up. I can do, the bigger one over the smaller one or vice versa, but I want to put x over 3 equal to 12 over 4 because x and 12 are coming from the same parallelogram. They are both in the top. 3 and 4 coming from the same parallelogram in the bottom, the denominator. I can also think of thinking like big and small. So I did big over small in both of these setups. Okay, now to solve this proportion, I need to think what divided by 3 equals 12 divided by 4. Now it might help to simplify this. 12 divided by 4 is equal to 3, so I need something. So when I divide by 3 is equal to 3. Another way to think of solving this is to cross multiply. So I take my numerator, denominator of 1, multiply them together. So I get 4x, 4 times x, and then 3 times 12. 3 times 12 is 36. So I have 4x equals 36. And then to isolate my x value, I will need to divide by 4. So this comes out to 36 divided by 4, which is 9. Now thinking back to how I started describing the proportion to begin with, I needed something divided by 3. So now that that's 9 divided by 3 equal to 12 divided by 4. And both of these ratios do come out to 3. All right, so trying that again, matching up my proportional and corresponding sides. I have 30 and 36, my unknown side, and 24. So I can do a different variable this time, whatever one I would like. And let's go ahead and see what happens if I put the sides of the same figure in a ratio? So this time I could do 30 divided by y equals 36 divided by 24. So y and 24 now are matching because they're the corresponding side. 30 and 36 are now matching because they are the corresponding sides. So solving this the same way, I'll have a y times 36 equals 30 times 24. So that's 36y. Oops, need my y there. Equals 30 times 24. And 30 times 24 does come out to 720. Dividing by 36. And I get y is equal to 20. So that means 30 divided by 20 equals 36 divided by 24. And I could put those both in a decimal, or I could end up simplifying them. Dividing 30 and 20 by 10 does make that 3 over 2. And dividing 36 and 24 by 12 will make that also 3 over 2. So I have my proportional sides correctly done with y equal to 20. Okay, we do have 2 more remaining. Now we have our figures in a slightly different orientation. Still, I'm going to match up my corresponding sides. And looking at them, I notice that LN is a bit shorter than LM. So that indicates that it aligns with EC, the shorter side there. And then for our longer side, 16 and 8. Now I might already notice in this, 16 and 8, that means to get from 8 to 16, I had multiplied by 2. I'm gonna go ahead and do dot. Now I need to think, I'm gonna take this then, multiply it by 2, and that would make my unknown side 10. Checking if these are proportional, I get 5 over 10, which should be equal to 8 over 16. And yes, these do both indeed simplify to 1/2. So that will make my question mark, which maybe I'll call M this time, equal to 10. All right, I want you to try this final one on your own and check back for the answer. Our final example, you should have gotten that P is equal to 30. Now that does conclude this lesson. Please let me know if you have any questions.